right. So hello, everyone. My name is Alex Cruz. I'm with Schneider Electric, and I'm a system architect expert, and I'm based out of Southern California. And today what I want to do is I want to spend the next 10 to 15 minutes kind of talking to you about our general purpose library and actually, hold on, can you guys see my screen? Just want to make sure.
Sure can.
Okay, great. All right. So I'm based out of Southern California, and so I want to talk about the general purpose library in conjunction with ASLink and how we can help improve that engineering workflow. So first off, what is the general purpose library? So it is a set of tested and validated libraries that have been created by Schneider Electric that follow a standard programming architecture that have the support and engineering backup of Schneider Electric. So it's a few set of libraries that cover a different set of devices, a different set of operations. But we also offer a set of specialized libraries that are separate from this general purpose library. And so those, depending on what industry you're working in, you can use or not use those. So, so what's the value add when it comes to these libraries? They're standardized. They're object oriented libraries that you can, they're ready to use essentially from the get go. You can kind of start putting them into your logic and control expert if you're using the Modicon libraries. And really, it's a nice way if you're not, if you're new to object oriented programming or those type of mechanisms. These libraries offer a great base in order for you to get started in that way. So the general purpose library is split up into two components. So the first component is what resides in the Modicon controller itself. And the second component is what resides in system platform or process expert, which is another Schneider Electric product. So with these two components, we can really combine the workflow. And so here in this next slide, we can see here, we have the library component that lives at the controller level. And then the library component that lives in the system platform environment provides these kind of ready to go faceplate templates so you can go ahead and start using them. Everything is auto created. So you don't, as you see here, right, we have different valves depending on the orientation. But all of that has been pre-generated. So with these templates, we have two versions. We have the GPL Classic version, which provides you a more colorful type of template profile. These are mainly used with the, if you're using the InTouch visualization. But now we have a version 2 of our GPL library, which encompasses the situational awareness style of graphic. And those graphics are primarily used with the OMI interface, while the classic version is used with the InTouch interface. So as I said before, right, we kind of have the Modicon library split up into 5 different categories. So we have the communication library, which helps interface, those Modbus or Ethernet, Modbus TCP/IP connections, and that covers both the implicit and explicit type connections. When we go down to the devices, now these encompass different types. So like we have our TSYS product line, which is our motor controllers. If you want to visualize power monitoring aspects or digital relays, or even our variable speed drives, we have those device libraries that you can then interlink down from the control level up to the graphical level. When we go into the diagnosis, we have different faceplate templates that can grab that information and display it into something that's more user digestible, right? So rather than having just a screen that's set up to intake those diagnostic informations, we have these faceplate templates. So like if you want to diagnose or you want to take a look at what the controller's doing, maybe the controller version, processor information, scan time, watchdog information, we have a faceplate template here that's dedicated to the Modicon M580 platform. Additionally, we have templates that can monitor the SCADA status. So hopefully you can see here, right? We have the app engine and some diagnostic information, and even the communication. So if you want to, see the status of your OPC client or see the status of your OPC server, we have those templates available. On the process side, we have the different categories for on-off devices. You can monitor analog device control. We have process control libraries that you can instantiate in the control expert programming environment, and then also monitor that in the system platform. Sequential control, which is ISA 88 compliant. So we have some of that too. And then, of course, we have some auxiliary functions that are part of that library. And then the last type of category that we have for the general purpose library is signal conditioning. So as we can see here, right, if you have an AI signal that's coming in, we have that. We have a library for heart, counters, and as well as digital inputs. So how does that kind of all fit in together? So because all of these general purpose or because all of these DFBs or derived function blocks are modular in Control Expert, it's a nice way to kind of build it the way that you want it, right? So we can see here we have the device control. If you have interlocks that are part of this device control, well then you can drop the interlock block and then start adding your start conditions, process interlocks, your trip conditions. If you have fault conditions that you want to have monitored, well then you can put them into Control Expert and start linking them. And then so you can kind of get that flexibility to kind of build your solution the way that you need it to. Right? We're not tying you to a certain block and be like, right, this is the block you have to use through all out. Right? We're giving you the flexibility to custom build these things. So when it comes to how the structure of these libraries is in Control Expert, is on the top half of the input side, you have your continuous control and basic configuration, right? So these are things that are internal to the PLC, right? If you want to enable the block, if you want to have the drive running, these are things that are internally. Then we can see here in the red, then you have your engineering parameters. And then in the green boxes is the data that is being sent and received from the device. So in this instance, we're using the ATV6XX, or the ATV630 or 600 series process drive. This is the block that we would use to facilitate the communications, or to have the communication data being fed into the logic, having been broken out to here, and then of course being used elsewhere in the logic. And then at the very bottom of this block is we have the status and configuration that is coming to and from the HMI. So it could be to and from system platform in this case. So as we take a look at how it all kind of maps to system platform, as we can see here, right, because it's an object-oriented programming manner, we take a look at this valve that's named HV 1001A. Well, when we pass this workflow into system platform, we can see that the name will match exactly what's in the code, and then here we have some interlock conditions which will also be fed into system platform. And we can see here the interlock descriptions as they've been made. Now, how does that link to the action or what the operator is going to see? So we can see here, right, we have the interlocks, which is we have a tab just specific for interlocks. The failures, right, we can see we have a tab just for failures. And then we have the option for a local panel that's on the HMI, which you can enable or disable. So when we're looking at the entire workflow, right, we can see here that the information that's being sent between the PLC and the HMI panel, this is what we see inside of the Control Expert programming environment. So we can see here the bits that are laid out here on the PLC side and how that correlates to the faceplate on system platform. So we have the libraries on both, right, on the Control Expert side, and we have libraries on the system platform side. But how does that communication or how does that workflow actually get done? And so essentially, we use a tool called AssetLink and the Modicon communication server. So what we do is we take the variable file or the XSY file, and we're able to feed it into AssetLink. So AssetLink is a tool that lives in the system platform development environment. And what that does is it looks at the variables that exist in that XSY file, and then it has a pattern or a XML template file that it has as a resource or as a database. So it sees the variable file and it sees what type that is. It associates it to that accurate template file, and then it'll start creating these assets in system platform. So of course, right, we have a generated or a set library that comes from Schneider Electric, but AssetLink isn't exclusive, right, to the libraries that we use. You can go ahead and create your own custom objects as well. You can create your own patterns, or your own XML, right, patterns in System Platform. So that if you don't want to use our Schneider Electric libraries, you don't have to. You can create your own and utilize your own. The Modicon communication server, what that does is it helps facilitate the communications from your server that's gathering all the I/O data and help it pass it to system platform. So when you install the Modicon communication server, you'll see it in your system management console as its own item in the list, and then you can point it to different PLC devices. It utilizes OPC UA communications to facilitate that communication. So all we have to do on our side on the Modicon PLC is enable our data dictionary. So essentially, right, we're moving away from Modbus registers, or we're moving away from assigning a tag, a Modbus address, and now it's all tag based, which is being facilitated. So from the PLC to the Modicon communication server, and then that data is being fed into system platform. And then from there, right, we can see that you can, from system, once you get your data into system platform, you can feed it into the AVEVA historian, and then further on, feed that information to AVEVA Pi. So if this is something that is of interest to you, we have different resources that you can take a look at. So the general purpose library is completely free. It doesn't cost anything to download. And when you download the general purpose library, files, you have a demo. It comes with a demo project. So we can see here, right? We have a sample control expert project. We have a Galaxy backup. So you can import that backup into, or you can, you can import it into System Platform, and it'll have an application that's ready to go. All you have to do is, fire up your a simulator, deploy it, and then so you can kind of see what the communication that's happening in between, your control expert project and system platform. Additionally, we have user guides and documentation that comes with the downloads. On YouTube as well, it's a great resource. We have various videos that go more in depth, of course, than a lot of time I have today, and it kind of shows you the step-by-step process of how to configure it, how to create your own, and then of course, if Schneider Electric support is always here to help you in any step of this process.